Hello, all. Welcome to the show. I'm Gus Gagliardi, and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Welcome to episode 26 of Fire Code Tech. In this episode, we have Wojciech Węgrzyński. In this episode, we talked to Wojciech about computational fluid dynamics, codes and standards in Poland, as well as some of the unique applications of smoke control and how that it's way more common in Poland than it is in the United States. If you're interested in fire science, this episode is for you. I really enjoyed talking to Wojciech. We've been connected for a while and trying to make this interview happen, and I'm super excited that I finally get to share it with the world. Wojciech has a litany of awards over the last 5 years and has been involved in over 25 peer-reviewed papers. What's fascinating is to me that on top of all these awards and this research that Wojciech's been involved with is he's coupled the commercial industry and how to actually design these systems and provide computational fluid dynamics to do the engineering study behind smoke control systems. I hope you enjoyed the show with Wojciech. Don't forget to follow us on social media and subscribe so you never miss an episode. Well, Wojciech, I just want to thank you so much for coming on the podcast. Yeah, thank you. Thank you for coming on the show.
Thank you very much, Gus. And we've talked about this for a long time, and I'm very happy that we finally can catch up and talk here.
Yeah, we made it. It's been I've been excited about this and excited to talk to you. So that's awesome. So
Thank you.
I wanted to
Likewise.
get yeah. So I wanted to get started with a little bit of background on how you got into fire science and how this field started to interest you and kind of how you got in it. Would you?
Yeah, so like most of people probably it was kind of accidental or I when I was facing a choice of the school to go after my high school, I've picked some universities, and the main school of fire service was one of them, because I had some family connections with fire service, and it seemed like a reasonable career. And yeah, that was the one that I got into. And once I got there, I really liked it. And a few years later, I found the computational fluid modeling and modeling fires, which was absolutely fantastic, and something that really popped in my head, and I absolutely loved it. And I was thrilled to be able to actually represent fires in a computer. So after finishing my university with a master's degree, I found this institute in Warsaw that was very well known in Poland as one of the lead companies that does modeling and in general does fire science at a great level. I've applied, I've been accepted, and yeah, a decade later, here I am, still in the same place and still thoroughly enjoying what I'm doing here, modeling fires and everything around that.
That's interesting to hear. Yeah, I have a similar story of stumbling in, as I think a lot of people do in our industry, stumbling into the field. But yeah, that's great. I would love to hear.
Yeah, you hear these stories all the time about people coming into industry by accident or just by random chance, or switching from structural, mechanical, electrical engineers at some final years of their universities, which kind of is a pity, because it's a such an amazing field of science and field of engineering that you can do. And I highly doubt there's any other field of civil engineering that gives you such an immense overview over the whole building process, from conception to basically the end of the building, and you have to be familiar with almost every branch there is of engineering, because the decisions taken by these people are affecting fire. And that's absolutely fascinating, and it's difficult to get this message to young engineers that such a field of work exists, and it's fantastic to be a part of it.
Yeah, I completely agree with you. It is such a great industry, and yeah, it's interesting that point you just made of how wide the scope of fire safety and engineering to make a more safe built environment or just environment in general. If you want to go broader than the design and the built environment, but yeah, it's such a promising field. I always am just kind of blown away how much of a well-kept secret it is, and how much the greater society kind of just is easy to not be aware of it your whole life if you don't know somebody who's in the field.
Uh, exactly. Hopefully it will change eventually. More and
Yeah,
more universities are having this fire engineering at least as a course during masters or bachelors, and more and more people are educated towards this. So yeah, it looks promising, I hope.
yeah, I think so. I think that it's just in the incipient phase of the profession, its lifespan. I think it's just still in infancy, and so we are just lucky to be in on the ground floor of a trade that has such promise. But yeah, it's pretty remarkable. I don't know how I got so lucky. A lot of times I think that uh, I stumbled into something so promising. But I wanted to get started with a little bit, or just I wanted to touch on a little bit more the different roles you've held at. Sorry, you told me the Building Research Institute.
Yeah,
Apologize.
yeah. ITB, yeah. So
ITB.
yeah, I've joined as a modeler basically. So I've joined the team of Mr. Storbala. He was my supervisor, and we've been doing some advanced CFD modeling of buildings of all kinds. And yeah, basically was the person who was doing the models and running the calculations, making the reports. So let's say basic engineer work. After gathering some experience in smoke control, I've been more and more involved in consulting projects and helping designers design more advanced systems, better systems. Because in Poland, the smoke control design is completely performance based. So there's a, let's say, a big market for such a consultancy. Yeah. So that was my few years, and after a few years, I figured out that I enjoy this a lot, and I started questioning some basic things that are obvious in the discipline, like why those axis symmetric plume relations give such a large number of smoke flow volume, or are we calculating the smoke temperatures correctly? And I was absolutely curious about how you can calculate these things. I've stumbled upon many interesting papers. I think the most influential was the PhD of Roger Harrison, and the papers by Harrison and Spearpoint on a spill plume design based on scale modeling. I was absolutely fascinated with that work, and I thought to myself that yeah, this is if I'm involved in designing buildings, I would really love to like go further and research why are we designing like this, not just follow blindly the obligations set in the standards. So that's why in 2013 I've decided to pursue my PhD in fire safety engineering, and luckily to me it was possible to do the PhD at my own institute, because ITB is able to award PhDs. So yeah, I've started my research on flows underneath projecting balconies and the influence of the architecture of the building on the smoke flows inside. And it was a fascinating journey. We've done a lot of simulations, a lot of scale modeling, everything while working as a consultant and as a commercial engineer. So it kind of took some time to catch up. And as I was progressing my research, I was touching more and more subjects related to fire safety of buildings, like growing my expertise, growing my interests into something like more holistic, and building the knowledge that I have today, building up new fields of research, touching new projects, doing exciting collaborations. And then it just snowballed with so many fascinating research projects. I've met so many great people who are fundamental to the scientific growth of our discipline. And I was really lucky to be exposed to them and learn so much from them. And today, this many years later, I'm a researcher. I still do modeling, I still do consultancy, and it's difficult to split your time in a half between this type commercial type of work and the research. And I love both definitely. And my commercial work affects my consultants, my research, and my research affects my consultancy. So I believe it's a perfect combination for an engineer to have. And yes, I enjoyed as much as on the first day.
Wow, that's fascinating. I love hearing about how you have had the ability to not only have the functional knowledge of how to, do modeling for the, buildings that are in construction and use that functional application to design buildings, but you've also had the opportunity to, chase your passions and dive into research. I would love to hear more about, a little bit on the how you interface with, the commercial construction because I maybe this instance happens in the U.S. and I'm just not aware of it. This kind of coupling with the commercial business and research, I'm sure it does, but I'm just not as ingrained in this field. But yeah, I'm fascinated by that. How does that kind of work? You working with do you work with consultants or I'm intrigued by that.
Yeah, so basically, we are, as consultants, we try to be a specialized company, or well, my group is a specialized group that does the CFD modeling and helps designer design better smoke control systems. We do not do the mechanical designs. We do not do building designs. Um, when we get hired, our goal is either to verify the solution as presented by the designers, and then we get into the CFD modeling, or be exposed to an pre-existing design and help improve that design with our knowledge. So the role is rather specialized, and we really like it like this. We're not interested in growing the package into like a full design from scratch to a project with stamps on and that you can send to the authorities. We are not that type of company. We are here to give the clients very specialized advice based on our experience, and that also means the types of the buildings we are involved in is kind of specific. We currently are involved mainly in road tunnels and railway tunnels, because there's a lot of ongoing tunneling projects in Poland. We get involved in all types of like underground railway stations, stadiums, skyscrapers, large shopping malls. Basically, the largest developments you can find in our country, but also in Europe. And yeah, that's quite nice because we get to work on the most challenging projects. And again, the scope that we are covering as the consultancy is fairly limited to the smoke control and auxiliary systems that will work with the smoke control. So it's manageable for the team to actually give that advice for such a huge projects that usually require hundreds of engineers to completely pull off. And we are proud to take an important part in the development of these projects. And for the research, that's like a second leg that we're standing on. As the institute, the institute is partially funded by the Ministry of Science and Higher Education in Poland. So there are some money for research and given to the ITB every year. So we compete for this internally with other research teams at ITB. We propose what areas of research are the most interesting to pursue. We design the experiments, and if they get funded, we get to do them. And the effects are obviously papers, conference materials, books, and stuff like that. And we also compete for like external grants in like the grant agency of Poland and Europe. That one is a bit tougher because the competition is much bigger, and sometimes you are feeling like it's more a random chance rather than a real review of the project contents. And it's kind of awkward system, but yeah, that's the system, so we play it. And we opt for this funding. We have just received a very large grant for wind and fire coupled modeling, so I'm super excited to have this to have the funds to continue this research for the next 2 years. And in the end, yeah, it's like it's 50-50. Some months there's more research, less commercial work. Some months are just full of commercial work, and you just have to balance it out somehow.
Well, I feel like you get the best of both worlds. The fact that you get to split your experience in these two vastly different fields. I mean, some of the same tenets and fundamental building blocks, but two
Yeah,
completely different fields, really.
and Gus, I often say that we do a selfish kind of science because the projects we are researching are usually the ones that mean something in our consultancy. Like there are wide fields with no data available, for example, or there are models that we know that are not the most efficient ones. There are magic numbers that we cannot track the origin of, and we are unable to engineer around them because it's a number, and you have no idea how to what will happen if you alter it, for example. So these practical problems we meet when doing the consultancy are absolutely affecting our science, and in a way there are drivers for the new research ideas we have. So it's not only like taking the both of the worlds, but in a way crushing them against each other, and yeah, using science to improve the engineering, and using engineering to do meaningful science. I think that's pretty cool.
Wow, that's really exciting and fascinating. I mean, I don't think that's selfish at all, wanting to, I think that sometimes research or education can get disjointed from the real world or, solving these technical problems. So I don't know, it sounds exactly what I would be interested in is taking these complex research topics and sharpening them to a point to, you know, help us be competitive commercially or, just make the science more stress tested and viable for everybody involved. So,
I would absolutely recommend to any like CEO or a person in a position to drive a large fire engineering company to invest some time and your best people into research, because you will be absolutely amazed what they come up with and how greatly that can affect the business aspect of being a commercial company. I believe that it's really beneficial for engineer to look on a problem with the eyes of a scientist and be like completely free to research the answer, to find the answer, and again be look to the problem through the scientific method, like without predicting what will happen, but measuring what will happen, um, testing your hypothesis, doing like a real research, and what you receive in the research, that's an outcome, and you have to work with it. You cannot guess it. You cannot like make it up. And then you're faced with some intriguing problems. Maybe you can find out that no one ever has found, and maybe you can figure out that a method we use for all the time we've used in the wrong way. And I think that it's beautiful, and if you do that, you not only improve your own quality of your consultancy, but you can make the whole discipline better, and help every other engineer progress towards the truth.
Yeah, that's awesome. I love that sentiment. Yeah, I think that large companies who are interested in doing business the most competitive way possible are interested in research and, as someone who works in a company who is interested in innovative technology and automation and, some of these advanced BIM techniques, I see that in the future, I don't know how people will stay competitive at a large scale without investing in some of these endeavors. But yeah, I think that's all great points, Wojciech. And I just wanted to kind of proceed in our discussion of, the built environment and, some of your career experiments with, or I mean, experiences with, I originally, when we were first talking, you had a paper that you sent me that you were a part of that went over some of the nuances and differences between like the US and some different building codes and for different nations. And I'd love to hear some insight from, what you see as the contrasts or similarities from, how the building codes and standards work in Poland, and then obviously how they uh, stack up to other nations.
Yeah, you're probably referring to the philosophy paper. I've sent it to you because we've just met, and you wanted to learn who I was, and that paper probably summarizes me as a person quite well, because it was at a very particular time in my career where I just took some time off, and just summarized everything done so far, and made some directions for the future. And the paper was in a way an outcome of this process. So I really like that paper. It's very focused on the Polish system, and Polish system is rather complex one in terms of how how it's built. We are obviously in the European framework, which defines a lot of things, but then we have our own building code, which rules how the building should be built. We have a separate fire safety code, which defines the principles of operations of buildings in terms to their fire safety, and that spans over all of the buildings, not only the ones that are just being built, but all of them. So there are many overlapping laws, and it's quite funny because, for example, the whole building code in Poland is prescriptive to the bone. It just defines you what you need to have in your buildings. Like it defines everything: distances, widths, lengths of evacuation routes, the classes of your walls, the type of your ceiling, literally everything. And then in the same code, you have one paragraph that says that smoke control systems should provide tenable condition on the evacuation routes within the safe evacuation time. And that's the most performance based way to define a system. you can have within the same law. So it's kind of full of contradictions, and sometimes quite difficult to go through. But with having this code, we could observe how Polish environment changed, how such aspects as smoke control and use of advanced modeling in the design of smoke control, that literally exploded. It's I would put a claim that we have some of the most advanced engineered systems for smoke removal in the world. Like truly every single building that's bigger than a house for a family, every single building is going through some sort of modeling, and advanced methods are used to design the systems in that building to meet the tenability criteria. So I think that's quite unique, because as I talk with colleagues from other parts of the world, it's not that common. Obviously, the advanced models are used, but not for every single project there is. So that's outstanding. On the other hand, we have some ridiculous requirements in terms of, for example, fire resistance of walls. To give you an example, if you build a skyscraper that's taller than 55 meters, your walls should be 4-hour fire resistant glass, which is kind of ridiculous requirement if you know how fire resistant works and what's behind it, and how can the fire develop in an office. So probably there is no need for 4 hour of the resistance. You could most likely provide the same amount of safety with 2 or 3 hour walls, and pump up some other active systems to compensate for that, and you would most likely end up with a much safer system and building. So in that paper, what we wanted to do with Dr. Sulik, my co-author, is we wanted to like summarize everything that's happening around the fundamental requirements of the European law in regards to safety, because that's the one that tells you what the buildings should do in case of a fire, that they should protect lives, they you should have evacuation, the fire should not spread, and so on and so on. So we wanted to summarize briefly what's happening in these areas in one paper that you could give to a civil engineer or architect, or someone who's not a fire engineer, and they would immediately have an overview how these systems are connected to each other. Because the thought that we have was that there are so many decisions made by non-fire professionals that are fundamental to the fire safety of the building. it's it makes no sense that these people do not have even the basic knowledge of the fire safety concepts. There is no way they can envisage the consequences of their decisions, which often can be profound, especially when we're talking about architecture of the building, the way how the building is shaped inside. And yeah, what we wanted to do with that was to give a nice introduction to non-fire specialists on how complex the fire safety is and how many aspects play together. And now, if you compare that to other law systems, it's difficult to me to do a comparison, because obviously I'm based in Poland, and I'm not an expert in the law of other countries. But as we discussed this with colleagues from SFP Europe, and we often have these types of discussions. Every country has its own flavors, and every country is fixated on something. Um, but it seems that it's still mostly prescriptive based everywhere. It's very rare that a whole country would introduce fully performance based engineering into their projects. I'm aware only of a few countries that have that, and I'm not even sure if that's possible in countries like mine, like Poland, to have it fully performance based, engineered. Not that it's something that's wrong, that I would not cherish. I would love to have the possibility to design the buildings to the best of my knowledge and experience. It's just that I'm kind of afraid what others would do with this powerful tool. And there are risks involved, obviously, with allowing people to do performance based engineering. And until we figure out the how to distinguish a good engineer from a bad engineer, how to measure competencies, how to prove competencies, it may be unfeasible to go fully performance based. It's a difficult discussion.
Yeah, definitely. Yeah, I don't know. The U.S. is heavily prescriptive. I would say much more so even than your description of Poland, as far as like in the several hundred projects that I've been a part of in my 5 year career, I've not once had a design that was performance based. So if that gives you any idea, and
Wow.
you know, uh, as far as another thing you touched on that really kind of blew me away was the smoke control. You touched on earlier how most of the projects you're involved with, these are all common facilities that we would see smoke control in the U.S.
Mhm.
High-rise buildings, buildings with atriums, arenas, stadiums, tunnels. I don't deal with the construction of tunnels, but I can see easily how the tenability of these spaces would have exceptional concern. So deep underground buildings, there are a set list of places where smoke control is required in the U.S. And there's a not a huge variety of these buildings, especially not in a state like Oklahoma, where I'm from, is very sprawling geographically, and so there are not as many high-rise buildings. So it's even less so, even fewer of these systems. So I was kind of blown away when you said that the smoke control systems were, or smoke control analysis and ventilation, and CFD was used on. Uh, it sounded like the majority of buildings. I was just really kind of blown away.
I would be surprised if it was not used in a bigger project. Like every single car park goes through CFD modeling. Every staircase that's larger than, let's say, five floors is going through CFD modeling. Every single atrium that requires smoke control will go through a CFD modeling. Every tunnel will go through a hell of CFD modeling, because these projects are very they have huge requirements in terms of quality of the system you deliver at them. So yeah, it's not even majority. I would say it's like almost all of them, literally.
That is wild. Yeah, and then another thing you said that blew me away was the 4 hour wall and how that's for the exterior of the building. That is a extremely significant uh, fire resistant fire resistant requirement for the exterior of a building. Generally, it's a very few cases with extremely dangerous hazardous materials in which we would require a 4 hour rated wall.
For that case, it even becomes more ridiculous when you look at it through the eyes of the scientist, because if you just consider a compartment thermodynamic system, that you have a fire in it and it's a small compartment, the amount of fuel in a typical office load, even if you count off the sprinklers, that let's say the sprinklers don't work and you just have that compartment, the fuel in it will most likely burn out within 1 hour, maybe 90 minutes after the fire started. So that's the maximum fire duration of a fully fledged fire you could expect in a compartment. Obviously, it's just a number, you can calculate that, but that's how it would end up in most of the cases. And if you have a very large open plan compartment, then it's also unlikely you'll have the exposure in one place for this many hours. I'm not sure if you know the traveling fire methodology, but it was developed in England some time ago, and it's fascinating new way to design structural fire resistance. But in principle, it means that fires are in a large open plan settings will be moving through the compartment as the fuel is being eaten by the flames, and you will either end up with a low energy fire that lasts for a very long time, but then your temperatures are not that high, or you will end up with a very, very large fire, but it will burn through the fuel very quickly within 20, 30, 40 minutes. So you end up with very aggressive fire, but a short one. And literally, it's not possible to find a physical explanation of a fire in an office setting that would create as onerous conditions as the standard fire for such a long time. And basically, it's unphysical. It's almost impossible to happen in a modern building, and
Wow.
yet it's a requirement of the law. This is why looking through the fire science on these things is so valuable, because I would never know. I would just obey to this requirement. And then let's go deeper. What's the consequence of this requirement? It obviously means you have to have the walls much thicker. You possibly might have to use additional fire protection of these walls, which you would normally not use. There's a very good chance you will have to increase the rebar depth in your concrete to protect the structural steel from the fires, leading into much bigger walls that you would need purely from the structural resilience of the building, and that adds to the weight of the building. So suddenly, because your building is weighing more, you add more strain to the fundaments. You probably require even more material in the bottom part of the building, making it even more heavy. And we had this project where the building was going slightly above an underground subway system, and we've reached the bottom line of the structural design of the building, where it was not possible to add any more weight to the building, because otherwise it would affect the subway system in a way that it was not allowed to. So you could not increase the weight of the building by an ounce. It was just the maximum, and yet to add the fire protection you would have to. So we've went quite lengths to prove that the building actually does not require this fire resistance, and it is very safe as designed. Thankfully, in Polish system, we have this derogation procedure where you can ask the ministry to allow you to fulfill a function, a requirement that's prescriptive in a different way that you propose, and you propose the countermeasures for that, and it was accepted, and that the building is now being constructed. But if you just obeyed the law, in the end you would not be able to build the building. So that's like quite ridiculous if you go purely poorly prescriptive.
Yeah, wow, that's a fabulous illustration of an instance in which a variance from what the building code prescribes and what you can show through performance-based design and science rooted in reality, what you can really do with the toolkit of being able to lean on performance-based design. That's pretty wild. Yeah, I'm super super interested about your discussion of the how you can either have a fire that reaches flashover and kind of its peak heat release rate, which is probably the more common occurrence in today's society, and how it'll basically starve itself out and not be able to last for this 4 hour wall. Like, yeah, that makes so much intuitive sense when you say that, but I've never thought of that. So since it's such a rare occurrence, I've only ever seen like a 4 hour wall in construction in the U.S. like maybe like once or twice as a firewall, as providing total building separation between two facilities. But yeah,
Yeah.
I think that's fascinating.
Yeah, it is, and that's just one of the requirements, and there are many like this where if you crush them with physics, with way how fires work, way how buildings work, you end up with requirements that do not make sense. For example, the root of the CFD in Poland of smoke control systems. That's actually quite funny story, because in early 2000s we had a law that said that in a smoke control system you have to place your exhaust grills not further away than 10 meters from each other. There was this one clause in the code that said that the maximum distance between the exhaust points is 10 meters. And suddenly, at some point, the jet fan systems were introduced into to Polish market. And Jetfan system is a system for car parks where, instead of having an array of ducts in your car park that remove the smoke from underneath the ceiling, you use a bunch of horizontal blowing fans to move the smoke horizontally to a single exhaust point located somewhere in the car park. So it's a different philosophy. And the obvious benefit is that you don't need ducts. At that point, the ducts were made with fireproof bolts, because there were no steel ducts allowed on the market that would have the required certificates. So the ducts were very expensive to be built. And then the Jetfans people came and said that you don't need the ducts; you can just put this fans underneath the ceiling, and it will work out. And then they were crushed with the law, because the law said you need to have grills 10 meters from each other. And you obviously cannot do that when you don't have ducts and grills, right? So these people were facing um, very big problem, because in principle their system was illegal. So they've started doing this CFD modeling to show that the systems are safe and that they can provide expected conditions within the car park as the system works. That's one thing. And then they were using this derogation procedure to ban that clause of the law for their project. And they were getting approval that, okay, for this project you don't have to meet this requirement of the grills. You can instead use CFD modeling to prove that the jet fan system is used instead and it's safe. And because it was at that point, it was such a big money saving for the investors to replace a traditional system with the jet fan system. I assume there was dozens, if not hundreds, of these derogation procedures flooding the office of the authorities. And at some point they most likely figured out that it makes no sense to give a derogation for every single building they meet. They just put the staple clause of the derogation into the law, which was this performance based clause that I mentioned before, that the system shall provide tenable conditions on evacuation route within the safe evacuation time. And with this, suddenly the jet fan systems became legal, and the benef- we're benefactory of that, because suddenly the performance based engineering was kind of maybe even accidentally allowed for all smoke control projects. So it all started with the ridiculous requirement of the grills being so close to each other, and a system that could not ever meet it because it didn't have grills, and a scientific view on the problem, because you could prove with experiments and simulations that even though you don't have grills, you still have a working system for your car park. And that led to the big change in the law. Maybe similar stories will lead to changes in different clauses of the law in the future. I would actually quite like that if that happened. Um, but yeah, moving into a full performance basis, as I mentioned, that's a different discussion and much more difficult problem.
Yeah. Yeah, I totally agree. I don't know. I don't know how that would work. I would be happy in the US if just, the authorities were more knowledgeable about performance-based design as an option. I'm sure there are many cities and entire states that uh, have never seen these designs or very rarely seen this even as an option. So I hear, other parts of the world, and how frequently that performance-based design is used. And I think of that as something to aspire for, let alone total, uh, everything being having the ability to be performance-based. But I think it's an interesting issue you raise about, how we need some way to verify competencies and modeling parameters and these sort of things. It's always seemed to me as an outsider looking in that it's such an art to be able to model a fire. I don't know if you have some more thoughts about that, and for for the audience and for my curiosities.
Yeah, well, it's definitely a difficult subject, and the field is full of magic numbers that are flying around and are being used by engineers and CFD engineers. In our case, the car parks are a really good example, for example, for Poland, because they were the first ones to be modeled such a massive scale. And in a car park, besides your ventilation parameters, obviously, the thing that will drive the outcome is the way how you model the fire. Obviously, that's the heat release rate, that's the soot yield factor of your fire, that's your heat of combustion of the car. And it also shows the dark side of this performance based engineering, because as these projects were commonly modeled with computers and accepted based on a computer on the results of computer modeling, we have also observed a trend that some of the companies, to win a contract over a competitor, were, for example, using a smaller fire to because it's there is no act of law that says that your fire in a car park shall be this value. No, it's all like engineering judgment, and there are resources that you can base your engineering judgment on. But I know resources that say it should be like 15 megawatts if you go into work of Joyer from France, and there are papers that say it can be like 2 megawatts if you go to like old Braunschweig experiments in Germany. So who is there to say which experiment is more real than the other ones? So it's kind of difficult to choose between them. And it was kind of nasty when the competition on the market started not on the quality of systems delivered, but on the boundary conditions of the simulations that prove that the systems work. Because if you're a designer, and let's say you design your system to withstand 8 megawatt fire in a car park, and I'm your competitor and I design mine for 4 megawatts, there's a great chance that mine will be much cheaper than yours because I will use less fans. My fans will have different temperature ratings and so on. And that's a very bad incentive to give. And money is king on the market, especially on cheaper projects like residential developments, where you have to force 200 people to pay for 200 flats and include the price of the structure built into their square meter price of the building. So you want to have the whole process as cheap as possible, and if you can save $1 million on your systems, then you would be very happy to do that. If it costed you just a simulation, and the fires do not happen, right? So why would you care that much? And in 2015, or maybe even earlier, we have noticed this trend in car park fires. And what we have decided, with my colleague Grzegorz Krajewski, was to write a book on how to design car park ventilation systems. And in that book, we took a very brave a move to explain in great detail how are we modeling the car parks. We gave like flat out what are the boundary conditions we use in the simulations, what is the fire that we use in the simulations, what's the soot yield, what is the heat of combustion, exactly the values that we are using in our common work that have not been changed since I believe 2005. We've never made them smaller because of a need of a project. And we gave it to the market, and it was not that we say, okay, from today the ITB says you should use these numbers. What we did is we went to many, like dozens of conferences, and we have clearly explained the people the differences that change of these parameters make. If we say that you should use, for example, 4 megawatt fire to simulate a single vehicle burning, if you use 2 megawatt fire, that is half of the smoke being released into the car park. That's something that layman can understand, and then it's like shines a bright light in their mind if they see a simulation on the half heat release rate, and they can then understand that the system is smaller, not because it's magically better, but because the simulation used to confirm it was done on the difficult assumptions. And the same for the soot yield. If you decrease the soot yield twice, you release half of the smoke into the car park. If you increase the heat of combustion twice, you decrease the amount of soot released to the car park by factor of two again. If you do all of these three things together, you release 8 times less smoke into the car park. And then it's very difficult to say that those two simulations are showing the exact same case and can be used to compare the systems proposed by different offices. So when we have flat out shown how it's being modeled and how these small choices of the CFD engineer alter the results and the outcome of the CFD, more and more offices were aware of the issue, and they were able to distinguish the true differences between systems, because they immediately knew that if someone approaches them with an offer that they can make a system significantly cheaper and then shows them simulation on like eightfold less amount of smoke, they immediately realize that, okay, can you repeat the simulation with this kind of assumptions? And then usually that office backed off. So in terms of car park design, we somehow put a stop to this practice with showing the design scenarios. And if you ask people who are professionally dealing with performance based design, this actually is something they do not really like, because the performance based design assumes a freedom of judgment for an engineer. You are the engineer who can determine the hazard, who can determine the applicable scenarios, the tools to be used, the criteria to be used in the assessment, and then determine if the outcome of your study is correct or not. That's performance based engineering. And then if you prescribe a part of this process, like prescribe the heat release rate of your design fire, you're kind of limiting this ability to engineer within the performance based engineering. So it's putting some boundaries on it, which for the most creative and competent engineers are not needed. But then again, there's the other part of the market for which giving them a complete freedom is as dangerous as not having PBD at all. So yeah, it's good to share the knowledge on how stuff like CFD modeling is being done. It's good to openly discuss it. It's very good to present this knowledge to other stakeholders in your process, who are not necessarily CFD experts, because there's not many CFD experts, to be honest. But show it in a way that they could understand how these small changes in the most critical parameters affect the outcome. And if these people get educated, the work of all of us becomes easier, because you stop competing with fraudulent engineers who would rather cut the fire in half and win a contract than design it properly and not win it. Yeah. I mean, I'm not. I don't know if it's a big issue in the U.S., but Poland in early 2010s, and that was early this century. It was an issue, and we came up out of this, and today it's quite nice, I would say.
Yeah, I think that there is probably, since it's so not common, I would imagine that, there's groups like Society for Fire Protection Engineers that's, working on trying to set some of these minimum parameters, if you will. But yeah, I think it's not a situation that's isolated to Poland. I imagined it's, something that can be found all around the world, that this thing where people are not, even if it's, if you extrapolate that outside of just CFD, I mean in fire and life safety in general, you can find those who have chosen to not, you know take the best case engineering judgment and provide the equivalent, product or ability to protect fire and life safety. So I think that this is a trend in the industry at large, that this minimum competencies and this value that we all find acceptable as true for equivalent life safety measures. But yeah, I really enjoyed that. I just wanted to ask about Wojciech, what projects or pieces of research uh, or projects or research things are you working on now? I saw some pictures on your Twitter of some, looked like some interesting uh, things being constructed, and you, it looked like they were going to be burned. So I feel like
Yeah.
I'd be kicking myself if I didn't get a chance to ask you about what you're working on now.
Yeah, we have a fire laboratory. There's always something being burnt. That's the beauty of this job. Um, Currently, we are the things that you refer to are most likely the STA SIG timber in fire project, which there's an alliance of timber manufacturers in Europe who wish to investigate how exposed timber can change the compartment fire dynamics in a very short way to say that. So it's a research on timber behavior in fire, in compartment fire scenarios, which will be absolutely fantastic, and I'm really excited for these projects. But there's a lot of ongoing research at ITB. For the starter, I just start with the large wind and fire grant, where we will use risk-based approach to quantify the wind effects on building fires, and to what outcome to what level the wind affects the outcomes of fires. And what's unique in this research is that I'm not really looking into the strongest winds or most onerous winds. I'm looking into a probabilistic distribution of winds on buildings, and I'm actually interested in the moderate winds and the ones that are most common. And yeah, we want to quantify what's the risk of both with wind and fire exposure at the same time. So I think this will answer a lot of questions regarding to what extent wind changes the outcomes of compartment fires, and when should we put additional effort to model wind, because modeling wind is a huge challenge. And yeah, we've learned that before, that it's not a simple task to include wind in your analysis. A second project that's really interesting is the facade project with Imperial College London. That's ongoing research with Dr. Bonner and Professor Guillermo Rain, and other students, Francesca Lugaresi and Benjamin Koo. We are burning a bunch of medium-sized facades with a Polish method to figure out how changes in materials impact the outcomes of the fires, to quantify the effects of the cavity. Francesca is doing numerical modeling of failure of mechanical failure of facades, so that's also super exciting. So in general, that field of fire science is super interesting and very exciting to work on. We're also researching smoke in corridors. We were building a large corridor facility to simulate compartment fires with smoke exposure to corridors. And yeah, we're doing much more. It's like you would be surprised how much parallel research projects are happening now, and all of them are exciting. These three are just the best ones for sure.
Wow, that's awesome. Well, Wojciech, I want to thank you so much for coming on the show. I would love to proceed down some of the paths of your research. I feel like the wind one is a whole podcast in itself.
Oh
I know
yeah.
we didn't get into that. I want to talk to you about that and your ideas since I know it's near and dear to your heart. But we'll have to have you on again. And yeah,
Oh
this is
yeah.
a lot of fun.
That's I hope that's a promise. When we have the first results of the project, I guarantee you will be the first one to hear that we have a breakthrough, and I would love to share it with your audience. Then.
That's awesome. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.